Okay, here I'm going to explain to you what is a chord and a tangent. Actually, this one I have already discussed in the class, but here I just revise. Okay, let's say I have a curve like this. It's a parabola. Okay, so if let's say I have a straight line like this, a straight line that cut at 2 points. This is P and this point is Q. Okay, therefore this is called the chord PQ. This is called the chord PQ. So if let's say the parametric equation is x equal to t square, y equal to 2at, let's say, that means this point the parameter is r, so it's q square 2aq, let's say like that. 2q, let's say no a, 2q, okay, easier like that. And then this point will be p square, the parameter is p square and 2p. This is the parametric coordinate, parametric equation of the curve, okay. So that means we have 2 points and this is called the chord PQ. Okay, then what is a tangent? Tangent means like this. You see the same curve and then this is the point P, okay, same way, same place, the point P, and then let's say this Q, it can be anywhere. Let's say this point Q, I move it until these two overlap, they meet each other. That means the Q also here. So when I join these 2 points, the 2 points with a straight line like this, so I join with a straight line like this, I take a ruler, I join with a straight line like this, then this is called tangent at P. Now this is called the tangent at P. That means at this point, this P is still P square 2P. And this point Q, because it already come to here, this point also P square 2P. So same. That means you change the Q into P. You change the Q into P, therefore then this is the tangent at P. Okay, another one. P is here, Q is here. Just now is Q move to here. What happens if P move down here? That means the P also come here. These two meet together. Then I join with a straight line like that. Now this one has become tangent at Q. That means for tangent at Q, now this point is still Q square 2Q. But this point also become Q square 2Q. That means you change the P to become Q. Then it's the tangent at point Q. Okay, so there is a relation with how to change a chord into a tangent. That means like these two different points, you can see these 2 points which are very far together, therefore this is the chord. But when these 2 points come together, then you say this is the tangent at P. When they meet here, then it's a tangent at Q. So likewise, anyone, let's say I have a point here, let's say this is the point where we call this point is the S, and these 2 points when they come together, this is the tangent at S. The tangent at S, like that. Okay, so with this, now I'm going to explain to you example 4. Look at example 4. Example 4, I show you here. You look at example 4. Now, example 4. Find the equation of the chord joining the point CP, C over P to the point Q, CQ, C over Q on the hyperbola xy equal to c square. Okay, hence deduce the equation of the tangent. You see, they ask you to find the chord and then they want to find the tangent at the point P. Okay, so how from the chord, how to become a tangent, I have already shown you. Now I show you the example. Okay, I show you how I solve it and then you can have a look. Okay, example 4. You are given the rectangular hyperbola. This is called rectangular hyperbola, is like this. Okay, so you see This is the Cartesian equation, xy equal to c square. This is given. And then if you look at the parametric coordinate like this, that means the parametric equation is ct c over t. Okay, the parametric equation is ct c over t. And then, so therefore, at the point P is Cp c over P, like that. Ct c over t. This is the general one for every point. So for this point Cp c over P, this is Cq c over P. So this is a chord. So you are asked to find the equation of the chord. We are going to find the equation of the chord. So you know the equation of the chord should be y equal to mx plus c, is it? That is because the chord is a straight line. And then how do you find the m, the gradient? So you just use y2 minus y1, x2 minus x1. So this one minus this one minus this. And then you just multiply by pq, so that is easier to solve like this. So you will get this, and then this one can cancel. Therefore, you get the gradient is this one. And then y equal to mx plus c1. So now you want to find the c1 because I don't want you to confuse this c with the c here. This c and c is different. This is the y-intercept. Okay, so we just substitute the point P here. Substitute the point P. Then substitute inside Cp. Okay, everything substitute. Then you can get the c. This is the c1. Okay, so therefore you get the equation of the chord. So equation of the chord, we just substitute whatever we get just now, the m and the c1, c2. Then we just simplify. We multiply by pq, you get this. Or simplify, we get this. This is the equation of chord pq. Okay, it's the equation of chord pq. So now what we want to do, hence we are asked to deduce the equation of tangent at P. So you want to find the equation of tangent at P. That means this point Q should come here. Correct? Now the Q should come here. That means when Q come over here, then it will become these 2 points will be together. P and Q will be together. So when P and Q together, it will become a tangent. And that means the Q you must change to P. So you see how I do it. There you see. P and Q come together. So then when you join the 2 points, it will become the tangent at point P. And then here, since we have already got the equation of the chord like this from here, then what we have to do, we just change the Q into P. We change the Q, because at first Q is here, that is Q, but now come here already. So it's already, so the Q become P. So you change all the Q. So when the point P and Q overlap at P, then the chord will become the tangent at P. Therefore, you change all the Q, to become P. So when I change the Q to become P, I change here, or here is the same. All the Q, I become P. So I will get this. So this is the equation of tangent at P. Okay.